Hi everyone, and welcome to another video from Eric's Electronics Workbench. So on the bench today I have this very nice Apt Corporation Holman audio preamplifier that was manufactured in the late 1970s. But it has a problem, that's why it's on the bench. So let's get started with the repair and see what it takes to put it back into service. So the owner of this Holman audio preamplifier said that the fault is that one of the channels has gone dead. So in just a moment I'll make some connections to an oscilloscope and also to my signal generator. We'll check out the performance of the preamp, kind of verify the fault, and then we'll go from there with the troubleshooting. But before I get started on that, let's just take a quick look around the preamp on the front and back panels and just get familiar with the controls and indicators. Now the owner of this said that they are the original purchaser of this preamp. They bought it new in the late 1970s. They also included this user manual. It's a very, very detailed manual, so the Apt Corporation put a lot of time and effort into this manual, not only on how to use the preamp, but there's a lot of theory of operation in here, so you can see many, many pages, a lot of detail in here. So it's nice that they included that as well. And of course there is a schematic in that manual, which could certainly be helpful with troubleshooting. But if you take a look at the back of the unit, or rather the bottom I should say, take a look at this. You don't see this very often on modern electronics, consumer electronics in particular. Complete schematic. So really nice to have that printed there, and you can see the technician that signed it off at the factory. But very, very nice to have that full schematic there. Very, very small print, but it is legible. It's laid out with the inputs over here working through to the outputs on this side. So very logically laid out. So certainly something that you just don't see on modern electronics. The ability to service them and have a schematic is something that's kind of forgotten these days. So let's take a quick look at the front panel. Start with that. Get you zoomed in a little bit closer here. So over here, the input selector, phono 1 and phono 2, a tuner, auxiliary 1, auxiliary 2. So pretty typical to have an input selection like that. Volume control has some nice detents when you turn it, very nice feel to it. Headphone jack right here, it's a typical 1/4 inch TRS type jack. The tape monitor loop selections right here, and then dubbing 1 to 2 and 2 to 1. Now these push buttons, when you press them, you can see there's a little indicator that opens up in the center right there, so that you can see them visually that they've been selected. So that's a nice feature. Moving over here, typical balance control, left and right channel balance. Now here's something you don't see very often. This mode selection, it's not really selection, it is variable, but the ability to vary from stereo, which is a center detent, and it says L plus R, so if you turn this all the way over, you get the left and right channels combined together, and if you turn all the way over here, you get the L minus R, the different signal within the stereo. So it's variable from one extreme to the other, and again, it's something that you don't see too often on preamplifiers. Bass and treble tone controls, very typical on that. External processor, so that just selects an external processor like an equalizer, and it lets you not have to tie up a tape monitor loop for external type processor. Now right here it says L and a little arrow pointing to R, and then R and a little arrow pointing over to L. So when this switch is up, what that actually does is takes the left channel and puts it onto the right channel, okay? If you take this switch and put it up, it takes the right channel and puts it over to the left channel, and when both of these switches are up, it reverses the stereo channels. So a number of different configurations that can be done there. The bass mode right here, you can see these two little symbols, and when this toggle switch is up, this top symbol is indicating that the bass tone control has a wider frequency response. When it's down, it's a narrower or lower end frequencies only that it affects. So a little more customization that can be done with that control. Tone defeat, when you turn that up, just defeats the tone section. And a high filter, when you turn that up, it attenuates high filters. So hisses and things like that. Possibly you could use that for a tape, something like that. Mute switch right there, it mutes the main output, but it does not mute the headphone jack, so handy if you do want to use headphones and then you don't want the main output active. And of course power switch. Actually I just noticed when you press that, that power switch is stuck in. That's going to need some attention. Also a power LED indicator right there. But yeah, that switch is not popping in and out like it should. So it seems to be in, which is good because it's in, so we'll be able to power it up, but we'll have to see why that switch is not functioning correctly. And let's take a quick look at the back panel. Make sure we're in the camera there. Yep, you can see that. So a number of AC outputs right here, switched and unswitched. So accessories that can be plugged in, and of course a power amplifier would typically be plugged into there. Right here, this little red cap that just comes off, that's a RCA type connector, but it's actually it says a positive 18 volt output, so some type of an accessory could plug into there. I'm not sure exactly what that was for, but 18 volt output. And then right here, a number of RCA connections, all the typical things that you would have for your inputs and outputs, your main output 1 and 2 right here, external processor loop I already mentioned, the tape monitor loops over here and so forth. You have Phono 2 right here. These are dummy plugs that are on the Phono 2, Phono 1 inputs right here. Here's a loading control 47 k ohm or 100 k ohm selection right there for the Phono section. And right here, the capacitance for the Phono section, and a ground stud, typically used with the Phono as well for eliminating ground loop hum problems. So very nicely laid out, and we can see all the different connections that need to be made on that to put it into use. So I will get some connections to one of the input sections and then monitor the output. We'll check it out and see exactly which channel is not cooperating and what it takes to do some further troubleshooting. So I think before I even start on that, I should take the bottom cover off. It looks like that this top cover is all formed. You can see these corners, are all one here. So the first thing to actually open it up would be this bottom cover. I'll do that. Let's just have a look around inside the preamp and make sure that there's nothing visually wrong, capacitors that are leaking or something, really visually a problem. If everything looks okay, then I'll go ahead and power it up. So I'll pull this cover off next. We'll take a look. So here's a tip to keep in mind when it's time to reinstall these self-tapping sheet metal screws. What you want to do is turn the screw backwards first, because you don't want to cut new threads in that hole. So if you go backwards first, hear that where it drops down in, it makes a little bit of a click. I'll do that again. Right there. When it clicks down, then go ahead and drive the screw in. It goes in very easily. No problem at all. If you just take the screw and start running it through the hole, you'll very likely cut new threads, and 1 or 2 times of that, and you won't have much left in that hole, and then it'll strip out. So just remember to turn it backwards first. Clicks a little bit, you'll hear it kind of drop down, and then run the screw in. You won't have any trouble at all. All right, I have the bottom cover removed, and at first glance, everything's looking okay inside the preamplifier, so I don't see any components that are overheated or a leaking capacitor or something like that. Nothing that would prevent it from powering up safely. So I'll go ahead and make some connections to the preamp, and then we'll start in on the troubleshooting. And tip it up here a little bit. You can see down inside there a little bit better. But it's looking very clean, all original condition, looks like, at least at first glance. And as always, if you're working on something like this, you're absolutely doing so at your own risk. Keep in mind there's exposed AC line over here. There's a warning note reminding us of that. So if you're following along, know the safety precautions when working on something like this. Always use an isolation transformer, and take care and be safe. Because again, you are doing so at your own risk if you're working on something like this. All right, I have my signal generator set to a 1 kilohertz sine wave at 300 millivolts RMS, and that signal is being applied to both the left and right channel. You can see that connection being made right here, and that's on the tuner input, so the input selector is set to tuner. And you can see we do have an output right now, a very nice looking sine wave on both the left and right channel. So this is the left channel, this is the right channel. Left channel trace up here, that's the right channel there. And if I move the volume control, you can see both channels seem to track okay, but it looks like a little bit of a static in there. I think that volume control needs some attention. You can see there's a kind of a flicker in that trace there. It looks like some noise being picked up right there. But they do track together, equal amplitude, so that looks very good. Certainly has the ability to have a lot of amplification there. So that looks really good. I don't think there's an electrical problem so far in the preamplifier, not from what I'm seeing. However, if we touch this tape monitor loop right here, turn that on, that's as expected. There's no output now because there's no tape monitor loop connection being made. If I turn that back off again, we have a problem. You can see a lot of intermittent connection going on right there. Then it comes back in. Now we lost it again. So that's definitely not right. So there's something going on with this switch. Either the switch is dirty or there's a broken solder connection on the circuit board. So we'll have to take some things apart, get a little bit closer look at that switch, and of course start by cleaning it, but also inspect the circuit board and see if there's any issue going on with the solder connections. Also, the tape monitor too doesn't seem to be in very good condition either. You can see both channels look to go dead, then one comes back in. That bottom trace doesn't lock because it's triggering on the other trace. So if I go like this to channel 2, there it'll lock in. But you can see a lot of intermittent connection on there, a little bit of fluctuation there. So definitely a problem. Now, leave that alone for a second. You can just go over here to balance. No issues there. It looks like the balance is working. I don't know, we can see some effect there. It's not a stereo signal, but it looks like there is some effect going on there. Bass and treble, we can check those out later. I need to change the frequency on that to see the effect on those a little bit better. Mute seems to work. Goes back in. And that mute control, I'm hearing a relay click, and there is a muting relay, so it seems like that relay is perfectly fine. It doesn't seem to go intermittent when the relay switches. It's very crisp when it comes back, no problem there. Moving some of these other switches, not really seeing any intermittent there. High filter, we can check that again later on. None of those really seem to cause any problem when you, again, like the processor, when you break that, the signal's gone, but it comes right back again, no problem. But going back to tape 1, very noisy again. So those switches really seem to be where the issue is at. Absolutely no output now, so very noisy, doesn't want to cooperate at all. So let me take this apart a little bit further and get some access into these switches, and we'll see what's going on. Alright, I now have the preamplifier disassembled to gain better access to the tape monitor switches that were giving the trouble. So this top board is able to be tipped up like so, and you can see down inside here, they switch right there, and the one next to it right there. Now, those switches are very well sealed up. I really don't see an easy way to get a lot of contact cleaner inside of them. There is a small hole where the latch mechanism reaches down into the mechanism inside the switch, so it's what causes that switch to lock in or release when you press it. So I don't think cleaning the switch on the circuit board is the best choice, because I think it would flood the whole circuit board with a lot of excess cleaning fluid, again because it's just so hard to work the cleaning fluid down into those switches. So I think a better choice is to desolder the switch and then clean it, away from this main circuit board. So I'll continue with that, and then when I have some updates, I'll be back. Okay, I've removed the tape 1 switch. You can see it was right there, and here it is on the bench. And as I was already mentioning, they're very sealed up, so there's a little hole right there. I think I can work some cleaner down into that. Very tiny hole there, and another one right there, but really nothing else on the housing of the switch. All of the pins have an adhesive glue along that edge, and really nothing else to get any access inside. I don't want to disassemble the switch any further, taking this top piece off, anything like that. I think it would end up damaging the switch. Really would be a last resort to try and open it up any further. So we'll see if it improves with some contact cleaner in there. Start with that. And I'll use a contact cleaner that has a lubricant in it as well. You don't want to leave it extremely dry inside, so that lubricant will help the switch to continue to operate correctly, but it'll clean up those contacts. So first of all, let's take a look at how this switch is actually performing the way it is right now. So if I take these test leads and just connect them together like so, you can see when they're connected, that's basically a good connection. That would be a close to perfect continuity. That's just some residual resistance that's in the test leads. All right, so that's what we're looking for through the switch, something very close to that value. And if we take a look here, I'll just connect this to this first set of terminals right here. Okay, so activate the switch. Right now those terminals are open. Okay, there's multiple groups of terminals that switch all in unison as the switch is moved. And if I press it again, so we can see we are all over the place on resistance. We're in megohms right now. There's kiloohms. It's auto ranging, but that's anything but a good connection. I mean, that is very, very poor and intermittent connection across those terminals right now. Now if I wiggle the switch maybe a little bit, it starts to drop up, get back up again. In the hundreds of ohms, and then into the, okay, now it's down into one, so we're 2 ohms of resistance, okay, 1.5 ohms of resistance. Better, but it should even be better than that, but that's better than those very, very high values. So It's really all over the place. If you press the switch again, it opens. That time seemed a little bit better. Very high values there again. In the k-ohm range, thousands of ohms, and then it drops down into about 2 ohms. So let me start working some cleaner into the switch and see if that switching action improves with some better results as the switch is moved. Then I'll be back. I'll report what I find. Alright, the switch has had a good thorough cleaning and I've actuated it many times, so let's see if it's functioning correctly. So it's obviously open circuit right now, and we'll activate the switch. Perfect. That looks really good. No problem with that. That's direct continuity right through the switch. Very stable, the way it should be. Try that again. So if I press the switch, opens up. And same reading again, no problems there. Let's just pick another set of contacts here. I'll work through all the different pairs of contacts that switch, but let's go around to the other side of the switch here and just pick another pair. I think these back two should work here. Yeah, so those happen to be closed right now, so no problem there. They open up. Very good, no issues with that. So that switch looks like it's working correctly again. So again, I'll just continue checking the rest of the switch, all the other combinations of contacts that switch, and then if everything looks good, I'll move on to the tape 2 switch and I'll get that out and we'll take a look at that out of circuit and then proceed to clean that one. Okay, so the tape monitor 2 switch has been removed, and you can see it right there. And it's connected to my digital multimeter, so we're measuring continuity through the switch. So right now, that's an open set of contacts. See, it says overload. So let's activate the switch. Yeah, it doesn't look too good. It takes a little while to settle in there. That's 2 ohms, but it was up in the thousands of ohms there for a moment, and still over 1 ohm there. So definitely it looks like that needs some attention too. So we'll go ahead and clean this switch up. Try one more time. Yeah, it doesn't settle in as quickly as it should, and then even when it is settled down, it still has some a little bit higher resistance there. So definitely needs some attention. Now, something that I didn't mention on the other switch, take a look here. So the way these switches actually function is that each group of 3 contacts is switched with a common in the middle. So for example, this center terminal is switched between this front terminal and then this back terminal, and then the next group of 3 is the same thing. You have this terminal switching between this front terminal and the back, and then this next group of 3 of this center terminal switching between the front and the back, and the same thing is repeated on the other side. So that's just the arrangement of contacts within the switch. So I'll go ahead and get this switch cleaned up, and then we'll try it again on the meter and see how it performs. Alright, the tape 2 switch has had a good thorough cleaning, and I've actuated it many times, so let's see if it's functioning correctly. So right now this set of contacts is an open circuit, we can see that. So I'll actuate the switch. Perfect, no problems with that, settles right in, very low value of resistance. Looks really good, no issues there. Pick another set of contacts. Now I'll go through the whole switch and check everything, but let's just randomly pick one over here on the other side. Say this one right here, and we'll go to this one here. Alright, so open circuit, and perfect, no issues there. Looks very good. Alright, so it looks like the cleaning took care of the issues that those switches were having. Now let's take a look at the power switch. Remember, I previously mentioned that it was stuck in the on position, so reposition things here just a little bit. Get this into the view here. I think you can see this. So if you look at the side here, there's a lot of old grease. Looks like in the mechanism, you know, that was factory applied, but that grease has probably gotten very stiff and dry in there. So get the camera zoomed in a little closer, you can kind of see the details of what's going on there. So you can see that grease that's in there, and then when I try and press this switch, see that mechanism just doesn't function. It's stuck. So I'll clean that up, and that should free up with no issues. I don't think there's any mechanical problem within the switch. It's probably just in that grease right there. And then I'll also go through the rest of the preamp on the other controls like the volume and balance and so forth, and clean those controls up as well. There was a little bit of noise that I was noticing on that volume control, so I'll get all of that taken care of, and I'll be back. Alright, the two tape loop switches are reinstalled on the circuit board, so you can see those switches right there. And I've also gone through and cleaned and checked all of the other switches and controls on the preamplifier to make sure everything else is in good working order. And as I previously mentioned, the power switch was getting stuck and not working correctly. So if I tip this here, you can see the switch is cleaned up, all that grease has been removed, and it is now working the way it's supposed to. So of course the switch is out right now, which would be off, so if you press the switch, it turns on, no problem like that. Press it again, pops back out. So that's working the way that it's supposed to. Now the owner of this preamplifier would like all of the electrolytic capacitors to be replaced, and that's good preventative maintenance on a unit of this age. So I'm going to get all of those electrolytic capacitors ordered up, and when they're here, we'll continue on. Alright, all the new electrolytic capacitors have arrived, so I'll get started on installing all of them. Now most of these new electrolytic capacitors are 105 degrees Celsius rating, with the exception of the axial leaded capacitors. I was not able to find those in that higher temperature rating, so they're still 85 degrees Celsius rating, but that's what their temperature rating was on all the original electrolytics from the factory in the preamplifier, so no harm with staying with that temperature rating, but it is nice to upgrade when possible to a higher temperature rating, and I generally do that when I'm replacing electrolytic capacitors. You can expect a longer life out of them. They're just not being stressed as much in the piece of equipment. Now this preamp doesn't get all that warm when it runs, but there are some heat producing components over in the power supply section, and there are several electrolytics in very close proximity to those components. So again, having that higher temperature rating is definitely a benefit. Now when you're replacing capacitors, you always want to go with an equal or higher voltage rating from what the originals were. Of course, within reason, you're not going to take a 35 volt electrolytic and replace it, say, with a 250 volt. Probably would be physically too large. There's just no reason to go so overboard. But within reason, so 35 volt, replace it with a 50 volt, something like that's perfectly fine. So many of these new electrolytics have a little bit higher voltage rating over what was originally in the preamp, but again, no problem, a nice safety margin in that. And then all the capacitance values are the same as what was originally in the preamp, and you always want to stay with the capacitance value that was in the circuit originally, unless you know what effect it would have if you change that value. And generally, you're not going to want to do that. Now, if you're working on a very old piece of equipment, you may come across non-standard values, say a half microfarad, where a modern replacement would be a 0.47 microfarad, and that's perfectly fine to make a change like that. But in this preamplifier, there were no non-standard values, so again, all the values remain the same. Now, I sourced all of these electrolytic capacitors from Mouser Electronics. In no way are they a sponsor. It's just a vendor that I prefer to use. I often buy components from them for the repairs that I do. So Mouser Electronics has a very good quality assurance program, and they're very strict on any fake components, so you can be assured that the capacitors that you purchase or any component from them is what it's purported to be. So these capacitors are Nichicon, Panasonic, Vishay, all very high quality capacitors. Now, in many of my previous videos, I've had requests for a listing of the capacitors that I've used, when I go through and change many of them, as I'm doing in this video. So I'll go ahead and put that listing up now, and if you're interested in that, you can go ahead and pause the video and you can see exactly the part numbers that I used. Alright, all the new electrolytic capacitors are installed in the audio preamplifier. So in just a moment, I will connect my signal generator and oscilloscope to the preamp, and we'll check out its performance and make sure that everything is working correctly. Now you can see all the capacitors that were removed, and in this group over here, they tested average for their age, no complete failures, none of these were leaking or any issues like that, but definitely some problems going on in this group right here. So let me zoom in the camera, pardon the movement here, and we'll take a closer look at those. See the meter a little bit easier here. So these two gray colored electrolytics were in the power supply section right next to those voltage regulators, and you can see this one was leaking, and you can see that brown stain on there. There was some corrosion on the circuit board, some corrosion on the lead of a diode that was right next to this capacitor. So that all was cleaned up, so no lasting serious damage, but it had leaked. And if we take a measurement here, And you can see with the meter connected, absolutely open circuit. So that one is out of there. And this one here, again in the power supply section, both of these are right next to those heat producing voltage regulators. So that definitely puts a strain on them. And you can see this one tests very poor with that ESR, 11.9 ohms resistance for the ESR, and then the capacitance value is 15.73 microfarads. This is actually a 22 microfarad capacitor, so that value is down. So all around, very poor performance on that one. Now all of these orange-colored axial leaded electrolytics were in the circuit related to that control I previously mentioned that varies between the stereo and then combining the channels to monaural, or you can vary it over to the difference signal. So again, these are in that part of the circuit, and all of these definitely have an issue going on. So if I disconnect it here, very high ESR on that one, 16.8 ohms. So it's giving us a 23.36 microfarad, and all of these are the same capacitance. Let's see, it was a 22 microfarad. Let's see the rating there. So again, all of the orange ones are the same rating, but very high ESR. So that one has definitely seen better days. And 6.1 ohms ESR. Very high. It's again not in very good condition. It's 7.8 ohms ESR. 22 microfarads on that one. So again, pretty high ESR. Almost 7 ohms ESR, very high resistance there. 21 microfarads, so capacitance was pretty close, but down just a little bit. And very high ESR on that one, 14.4 ohms, and again the capacitance value is down. Now, bear in mind that this is giving us an ESR reading and a measurement of the capacitance, and it's doing so with a very low voltage test. I did not run any of these on my leakage tester, and I'm sure that with the actual applied voltage up to the rated voltage, they would probably have a very high leakage. And some of these others that were removed, I didn't run the leakage test on them. The ESR is average on them. They're not that great on any of them, but none of them stood out as complete failures. But again, the leakage could be a whole different story when you actually put the rated voltage to the capacitor and measure any leakage current through it. But really no point in doing that because all of them just needed to be replaced because of the age. Any of them could leak at any moment, so you know, definitely good to just do a wholesale replacement and get all of them changed out. So the next thing that I'll do is make some connections to the preamp, and let's check out its performance. All right, let's run some tests on the preamplifier and make sure that it's functioning correctly. So you can see we have a very nice looking output signal right now. We'll take a closer look at that in just a moment. But with all of the capacitors that were replaced, let's make sure that the power supply sections are working correctly. So let me take a test probe here and go to the negative point, and there are two power supply rails. There's a positive and a negative supply. So if I go to this point right here, so this is the unregulated supply. You can see we have 24 volts, a little over 24.4 right there, and then very low ripple, about 136 millivolts of ripple, so no issues with that. And over here there's the negative supply, so negative 24, and about 180 or so millivolts of ripple, so no problem there. Very, very low values. So now let's take a look at the regulated side. I expect to see a much lower ripple on that point, and of course the voltage is lower because it's regulated. So let's see, this point here should be one of the rails. So we have negative 18, so that looks very good for the negative supply, and you can see the ripple voltage is unmeasurable. It's just sitting at 0, so very, very good. And this should be the other supply, and it is, so 17.9, so almost 18, no issues there. And again, the ripple is unmeasurable. It's just sitting at 0 volts AC. So power supplies are functioning the way they should. So we can move on to the remainder of the testing. So right now my signal generator is set to a 1 kilohertz sine wave at 300 millivolts RMS. And this is the left channel, channel 1, and then channel 2 is the right channel. So this top trace is channel 1 or left, and this is channel 2 or right channel. So initially the volume control was a little bit staticky, so let's make sure that that issue is taken care of. So I'll turn this all the way down. Let's go all the way down here. So this is 20 millivolts per division. So very low output right now, and that looks very good. I don't see any static. Signal looks fine. No problems there. Yep, that looks very good. So also let's make sure that the channels are tracking equally in amplitude as the volume control is rotated through its full range. So again, we'll turn that all the way down. Go over here to put 2 volts per division, and I will put the 2 traces on top of each other. So, all right, so you can see the 2 traces are just overlaid. And when the amplitude is equal, they should just appear as one signal. So we'll start increasing this up. No problems there. So if I separate those, you can see like that. The 2 traces, and they overlay perfectly like so. So that looks very good. No problems there. Back over here. All right, let's take a look at the balance control, make sure that's working correctly, and it is. No problem with that. And we don't have a stereo signal, so the left plus right remains the same. That's just combining them, and the left minus right is all the way down, so that's fine. Bass and treble, let's make sure that those have a correct response on the frequencies. So I'll drop the frequency down. Let's go down here to 100 hertz. That's about the best I can do on the flicker, pardon the flicker on the screen there. I think that's about the best we can do. So we'll rotate the bass control for some boost, and yes, we do have a lot of boost there, and the cut works fine. So if I go over here and then we take this bottom switch and go down, yep, there's less effect right there. That's correct. That's how it's supposed to function. And let's go up to, let's say, 10 kilohertz. All right, there's 10 kilohertz. And we'll adjust the treble control. Yep, no problem there. Cuts down. Take a look at that high filter. Yep, does have some effect there. Let's go back over here and we'll go to all the way up to 20 kilohertz. High filter, yeah, a lot of attenuation at the high frequency there, so no issue with that. If we have the treble up and we do tone defeat, yep, bypasses it, so those are all working correctly. And initially, of course, the problem with that tape 1 and tape 2 switches, so we can see no problem there with tape 1, tape 2, no problem there. So all of that intermittent problem is now taken care of. That's working the way that it's supposed to. So let's make sure that the gain of the preamp is flat across the complete audio spectrum from 20 hertz to 20 kilohertz. So I'll put the tone defeat switch on so that it bypasses all of the tone sections. I'll go down to 20 hertz. All right, there's 20 hertz. Pardon the flicker on the screen. Slight adjustment there. So you can see the top of this trace comes up to that graticule right there, and the top of this trace is right at the center graticule, all right? And the bottom of the trace is touching that graticule. The bottom of that trace right there is coming right down to that center graticule. So what we want to see is as we adjust the frequency all the way up to 20 kilohertz, that those amplitudes should remain very, very close. It really shouldn't change. So I'll start to increase this. Let's go up to, again, let's say 500 hertz. So no problem there. The amplitude is the same. Let's try 1 kilohertz. No problem there. Amplitude looks exactly the same. Let's try 5 kilohertz. Yep, very good. Amplitude is remaining flat. And let's try 10 kilohertz. And that also looks very good, no problem there. You can see the amplitude is still touching that top graticule, the bottom, middle graticule down there, so that looks very good. And let's try 20 kilohertz. So you can see 20 kilohertz also looks very good. The amplitude is the same as it's been at all the other frequencies. So the preamp has a flat response, and that's exactly what you want to see. If the tone sections were engaged, then of course the response would vary across all the different frequencies, and you would adjust the tone controls to suit your preferences in the music and your speakers and so forth. But the preamp, just in its basic amplification through the entire chain of circuitry, has the ability to remain flat, and that's what you want in its response. Here's a 20 millivolt RMS signal being applied to the Phono 1 input. The Phono stages have their own separate preamp within the preamplifier because Phono inputs accept a very, very low signal level from the cartridge in a phonograph. And I stepped through the entire frequency range, and the response is correct on the Phono stages. So again, we're on Phono 1 over here, and that signal looks very good. Let's take a look at Phono 2. Alright, we're on Phono 2 input. You can see the selector switch has been changed, and the signal looks very good on the output. No issues with the Phono 2 section. Alright, the final thing that I should check is the headphone output signal. So I'll grab my scope probe here, and I'll just clip the ground lead onto the chassis. And I can see down in here there is a connection for each of the channels on the headphone connector. So I'm not sure if this is a left or right channel, but it doesn't really matter because we'll check both of them. Have a little bit of a signal there. I'll increase the volume. Oh yeah, look at that. There's a lot of voltage swing there. No issues with that. So that was on 2 volts per division. Here's 5 volts per division. And there it clips right there, and the volume is absolutely at its maximum. So no issues there. There's a lot of voltage swing. That's 5 volts per division. So it looks very good, no problems with that. I'll leave it set right there. So actually go down one more. Let's just adjust this up a little bit there. So we have exactly 1 graticule of deflection above and below the ground reference. So I'll leave it set there, and I'll clip this onto the other channel. Right there. Yep. All right, and has the same amount of deflection, so the equal gain, equal output drive on both channels. So that looks very good. Increase this. Again, a lot of deflection there, and it clips right at the same point, right when the volume hits its maximum. So when it's clipping like that, the volume is all the way at its maximum, and I have a 300 millivolt RMS signal going into the preamp. So that's working the way that it should. That looks very, very good. And again, this is 5 volts per division. So the preamplifier is definitely functioning well, and it's ready to put back into service. So I connected this Holman preamplifier into my audio system and spent some time listening to it. And let me tell you, it sounds absolutely fantastic. Really happy how this project turned out. It's working very well at this point. I also connected headphones to it, and it plays beautifully through the headphones as well. So if you enjoyed this video, don't forget to give it a thumbs up. And if you're enjoying the videos on this channel, please remember to subscribe. There'll be many more videos like this coming up in the near future. So until next time, take care. Thanks for watching. Goodbye for now.